Hello everyone, I am Sriv aka CrapTheCoder, and in this video we are going to be discussing fast IO in C++. First, let's talk about what fast IO actually is. Fast IO or fast input output is an optimization for cin and cout in C++. The performance difference to normal IO is negligible for small inputs, but it has a huge impact for larger inputs. There are many disadvantages to using fast IO though, which we will be discussing later. But just keep in mind that fast IO should never be used in production code. The most straightforward way to make IO faster is by using scanf and printf instead of cin and cout. The downside with this approach is that scanf and printf are much harder to use than cin and cout, as they are an old feature from C rather than C++. Generally, most programmers prefer cin and cout for this reason. Therefore, we are not going to be discussing scanf and printf in this video. But it is possible to make cin and cout as fast as scanf and printf by just adding the following two statements before taking any input. The first statement is iOS sync with stdio false, and the second statement is cin.tie null. Do keep in mind though, it doesn't magically make our code faster. It is important to know how exactly these statements make our code faster as well. Let's first go through the first statement. This statement removes the sync between cout and the printf functions. Let's take an example for that. Here we can see that I'm outputting 1 and then I'm doing printf 2 and then I'm outputting 3 and then I'm doing printf 4. So if I run this, I would normally expect to get 1, 2, 3 and 4 in order. Let me comment this function and show you the output first. So if I run this now, I get 1, 2, 3, 4 as expected. But if I add this statement, let's see what happens. Well, you can see that I get 1, 3 and 2, 4. Which obviously means that the sync between cout and printf have been removed. All the cout statements are outputted first and the printf statements come next. The second statement removes the sync between the cin and cout functions. This makes it so that all the input is taken first and the output is shown after the program ends. Again, let's take one example. In this case, I have int x and then I'm outputting first input and then taking input of x. And then I'm taking int y, second input and cin y. And at the end, I'm just printing the product of these two numbers. Now, let me comment this again and let me run this code. And well, I get first input. I can enter something like 10. Then the second input can be something like 5. And then I get x times y equal to 50, which is what you would expect again. But let's uncomment this line. And now if I run this, well, you can see that it actually doesn't output anything. But if I do enter 10 and then if I do enter 5, you can see that all the output is outputted immediately. Again, this is due to the fact that cin takes the input before it outputs anything. It outputs everything at the end after the program ends. As long as you only use cout, the first statement won't affect you in any way. So there is no point in not using it. The second statement, on the other hand, does affect you though. If you are testing your code, you won't be able to see any output until the program has ended. The output will also not be visible in case your program crashes. For example, in this case, I am taking an input of 4 pairs of numbers. Then I am outputting the sum, product, division, and the difference respectively. Now, if I take a test case like this, then let's say that it was actually 4-1. Now, if I run this without the cin.tie null, well, you can see that I get the proper output. But if I did take 4-0 here, then this should crash the program as e/f is not possible. 4 by 0 is not defined and that will raise an error. So if I run this, as you can see, it crashes after outputting the first two statements. But if I did take cin.tie null, and let's take the first test case again. So I had 4-1 here, then I would expect it to work fine. But if I did take 4-0, well, you won't be able to see the first two lines either. So you can't really figure out the issue. In the other case, we know that the first two lines work fine. Therefore, the issue must be in the third line. Well, that's not possible here. Here you can't even tell whether the issue is in this line or whichever line. So, when debugging your code, you should comment out your fast IO. Also, using fast IO for interactive problems will make it so that your code always fails. Again, we'll be discussing this in a bit. It is also important to note that you should use \n instead of endl. Before that though, let's talk about flushing. When using cin.tyNull, the outputted statements are stored in a buffer, which you can imagine as a temporary storage. When you flush a buffer using cout flush like this, when you use cout flush, the buffer is cleared and everything in it will be printed. So if I run this, if I enter 10, I get 10. But when I enter 20, you can see that I don't get anything. And only after I enter 30 do I get the entire output, because then the program has ended. And if I take the cout flush here over to y, then if I run this, if I enter 10, I do not get any output. But if I enter 20, I do get the output. And again, this is because flushing clears the buffer and it prints everything in that temporary storage. But obviously, flushing is a lot slower than not flushing. And the issue is that \n does not flush, but endl does flush automatically. So if I take endl here, even without flushing, so if I run this without flushing, well, you can still see that it is flushing. So it is slower than using \n. So if I had taken \n here, then it would not in fact output anything unless I use cout flush. So if I run this, you can see that it doesn't output anything unless I use cout flush. Therefore, endl is slower than \n and it basically negates the effect of cin.tyNull. The reason fast.io does not work with interactive problems is that the judge needs to read your output. The judge reads your output and returns some input. But if your output is only shown when the program ends, then the judge has nothing to read and hence responds with nothing. That's why we get an idleness limit exceeded or time limit exceeded error when fast.io is used with interactive problems. Also, fast.io should not be used in production code because execution time does not matter as much as it does in competitive programming. You run the risk of introducing bugs and creating unnecessary confusion in order to save only a couple of seconds when running the code. Let's just take a quick summary of what we have discussed so far. First of all, fast.io makes cin and cout faster, and it makes it as fast as scanf and printf. It can be used by adding iOS sync with stdio false and cin.tyNull. It removes the sync between cout and printf and also removes the sync between cin and cout. And \n should be used instead of endl, as endl flushes automatically and this slows down the code. And fast.io should not be used for interactive problems, when debugging and when writing production code. And yeah, that's all for today's video. If you have any queries or anything to add, please do let me know in the comments. You can also join my Discord server. The invite link is in the description. Thank you everyone for watching, and please do like and subscribe if the video was helpful. See you again in the next video. Bye.